This is a friction problem. It talks about the coefficient of friction between a block and a tabletop. So as usual, the assumption is that if you've got a block on a tabletop, it's a horizontal tabletop. It's a flat surface. It's a level surface. If you look at this kind of description, the assumption is a horizontal surface. As usual, first thing, draw a picture. Draw a force diagram to be more specific. We've got a normal force and a weight, which I just labeled mg because you should get used to the idea that weight is mg because force weight is equal to mg. And it says it's dragged horizontally. I don't know what this force is yet, so I just labeled it. I just drew a force in there. I don't know what it is or how much it is yet. I just drew it. But I know that in whatever direction this is going, let's say it's going to the right as a velocity, not necessarily an acceleration, or it could be an acceleration or a velocity. Well, let's say it's moving to the right. Then the friction must be going to the left. Normal force goes perpendicular to the surface. Weight always goes straight down. I know those two are equal. And there's no net force in the vertical. Again, as usual, if anything I'm saying doesn't make sense, you should pause it, rewind it. First thing I'm going to do, because the question is what is a frictional force, I just write down my equation for the frictional force. It says force of friction is equal to this funny looking thing times the force normal. This is coefficient of friction, so let me just explain why this equation really does make sense. It makes sense because one thing that should factor into the friction is the roughness of the surface, and this coefficient of friction is basically a measure of the roughness. It's kind of like a percentage. In this case it's 0.34. It's kind of like a percentage of the normal force that translates to a friction. So this is about 34% of whatever that force is, that normal force, is the friction. If that were like 0.67, it'd be 67%. But it's a representation of the roughness of those two particular surfaces together. So you can imagine like rubber on sandpaper would be an extremely high coefficient of friction, and something like an ice skater's blade on the ice would be very low coefficient of friction. They're usually less than 1. And I believe that's in the notes that you've already taken. Now, part of that formula involves the normal force, so I just need to get the normal force. Now this is why the diagram is so important. If you didn't understand the diagram, you can't really do this. The diagram clearly shows that the normal force is equal to the weight. So if I just calculate the weight, I've basically got my normal force. So it's very easy to get. Force normal is equal to force weight, which is mg, which is 4 times 9.8. So the force normal is just 39.2 newtons. So all the concepts are out of the way. The rest is plugging and chugging. We're going to plug back into this equation, this force of friction equation. I'm going to use that down here. The force of friction is equal to mu times the force normal, which is 0.34 times 39.2. And people often ask me what that symbol is. This is a better drawing of it. I did this drawing actually on a whiteboard last year. This one I'm doing at home, and it's kind of hard to do on this tablet. But it looks kind of like that. It's like a cross between an M and a U. And the answer is just 13.3 newtons. So we just calculated the frictional force. The next logical step, we'll go back to this. That's the frictional force, which we're going to use. The next logical step is, if that horizontal force is 20 newtons, find the acceleration. So now, it's the same problem, new part, same diagram. But now we're interested in finding the acceleration. And I wrote sigma f equals ma, and then I added these subscripts x. Now stop and think about that for a second. This is not accelerating vertically. This is accelerating horizontally. It's on a horizontal surface. It's on a flat, level surface, a typical surface. It's accelerating across the surface. And that acceleration is caused by the 20 newtons, but it's not really a full 20 newtons that's accelerating it. So we write down sigma f equals ma. And now we're going to ask ourselves, what are the forces? What are the forces that are actually accelerating it? Well, there's a force of 20, F minus F sub F. Why are we subtracting? Because that's positive and that's negative. You know, if they were together, then we would have added them, but they're subtracting. There's really less than 20 newtons actually accelerating this thing. And I put A sub x, again to emphasize that it's the acceleration in the horizontal that we're interested in. So what I did here with the blue arrows that I just deleted is I was simply checking off the stuff that we know. And the stuff that we know is we know the force of friction from the last slide. We know the mass. It was in the last slide. It was 4 kilograms. And we know this force F. So I'm not going to bother showing you how to do all the plugins. It's 20 minus 13.3. Then divide that by 4 and you get 1.67 meters per second squared. And if on a quiz I ask you for the direction, you would say to the right based on this diagram. But look at the problem. The problem never actually specified what direction. It just said that there's a horizontal force. Well, let's go back here. Maybe I did specify. Nope, it just says it's dragged horizontally. So all you can say is the magnitude of the acceleration is 1.67. Quick recap. At this point you can just stop the recording if you completely understood what was just said. But the diagram was really important. This is on a horizontal surface, so you know there's a normal force involved because it's always perpendicular to any surface. There's always a weight straight down. And there's a force that's got to be causing this thing to move horizontally. We don't know what it is yet. And there's friction. And the question is simply, what's the frictional force? You write down the equation. This is the coefficient of friction, which represents the roughness. You multiply that coefficient of friction by the normal force. So the question is, what is the normal force? It's equal to mg in this case. The diagram clearly shows that. So you just do an equation for mg, which is the weight, 39.2. You plug in, you get the friction. In the next slide, you just look at the forces that are causing the acceleration. It's just 20 minus 13.3. And it's equal to 4 times a. Plug in, solve. Acceleration is 1.67 meters per second squared.